Have you ever looked up at the sky and wondered how something so heavy can stay afloat? Airplanes, those giant metal birds, seem to defy gravity. They carry hundreds of passengers and tons of cargo, yet they soar effortlessly through the air. The secret lies in the basic principles of flight, a fascinating interplay of forces that make it possible for these machines to grace the skies. The key to understanding flight is understanding lift. Lift is the force that opposes gravity and keeps the airplane in the air. The shape of an airplane's wings is crucial for generating lift. Imagine holding your hand out of a car window. When you tilt your hand slightly upward, the air pushes against it, lifting it up. Airplane wings are designed with a similar shape called an airfoil. The top of the wing is curved, while the bottom is relatively flat. This shape forces the air traveling over the top to travel a longer distance than the air traveling under the wing. Because the air on top has to travel further in the same amount of time, it moves faster. Faster moving air creates lower air pressure, while slower moving air creates higher air pressure. The higher air pressure under the wing pushes up against the lower air pressure above the wing, generating lift and pushing the airplane upwards. As the airplane moves through the air, it encounters resistance. This resistance is called drag. Drag acts in the opposite direction to the airplane's motion, trying to slow it down. It is caused by the friction between the airplane's surface and the air molecules. Think about running against a strong wind. The wind pushes against you, making it harder to move forward. Drag is similar. The shape and size of the airplane, as well as the smoothness of its surface, affect the amount of drag it experiences. Section 4. The power of thrust. To overcome drag and propel the airplane forward, we need thrust. Thrust is the force that moves the airplane in the direction it wants to go. It is generated by the airplane's engines, which can be jet engines or propeller engines. Jet engines produce thrust by sucking in air, mixing it with fuel, and burning it in a combustion chamber. This process creates a powerful jet of hot gases that is expelled out of the back of the engine, propelling the airplane forward. Propeller engines, on the other hand, use spinning blades called propellers to push air backward, generating thrust. Section 5. Balancing act in the air. For an airplane to achieve stable flight, it needs to maintain a delicate balance between the four forces of flight: lift, drag, thrust, and weight. Weight is the force of gravity acting on the airplane, pulling it downwards. During level flight, the amount of lift generated by the wings is equal to the weight of the airplane, keeping it from falling. The thrust produced by the engines is equal to the drag acting on the airplane, allowing it to maintain a constant speed. To climb, the pilot increases the engine power to generate more thrust, which increases speed and allows the wings to generate more lift. To descend, the pilot decreases engine power, reducing thrust and allowing the airplane to descend gradually. Section 6. A simple experiment. You can experience the principle of lift yourself with a simple experiment. Take a sheet of paper and hold it horizontally in front of your mouth. Blow air over the top of the paper. You will notice that the paper rises. This happens because the faster moving air above the paper creates lower air pressure, while the slower moving air below it creates higher air pressure. The higher pressure below pushes the paper up, demonstrating lift in action. In conclusion, the ability of airplanes to stay in the air is a testament to the ingenuity of human engineering and the power of understanding basic scientific principles. The interplay of lift, drag, thrust, and weight allows these magnificent machines to soar through the sky, connecting people and places across vast distances. So, the next time you see an airplane gracefully gliding above, remember the fascinating forces at play that make it all possible.